Alright, let's continue with another two grayscale transformation, which is the log transformation. In the previous video, we already looked into negative image and also gamma transformation. Now we look at another transformation, which is log transformation. So the log transformation has two. The first one is the normal log transformation. Another one is the inverse log transformation. And the equation for the log transformation is given by this. Let me take the pen from here. Is given by this formula, where S is the output gray pixel value. This is the output, and then your R here is the input gray level value. And the C here can be constant. Normally, we just take the C is equivalent to 1. So this transformation maps narrow range of low gray level value in the input image. So normally, when you have the input image that has the low gray level value, meaning that like this image, so most probably, when you look at this image, it has low contrast. And you can see that it has a narrow range of low gray level value. Maybe it's around here, and all scattered at all accumulated at one place like this. Okay, so the dynamic range of this image is very narrow, as you can see by here. So you can use, if you have this kind of images where the contrast is very low, where you cannot differentiate between the background and also the object here, the one that you are looking at here, the area here. So if you have the low contrast image, you can use log transformation in order for you to enhance the image. And you can always get back the original image by computing the inverse log. So the opposite is true for higher value of input level, that this type of transform to expand the value of that pixel in that image while compressing the higher value of higher level value of the level. So you can always get back the original image by computing the inverse log. So the log function has the important characteristic that it compresses the dynamic range of image, okay, with the variation of the pixel value. So that's the function of log transformation. So if you have the image that is accumulated at one area only, and due to that the image are low contrast, you can apply log transformation. So and the last Grayscale transformation is contrast stretching. So let's look at what does it mean by contrast stretching. So if you have the original image that has the pixel range around this, so 79 to 136, so if you plot this on the histogram, and you have the lowest pixel equivalent to 0, and the highest is the white pixel 2.5, 79 and 136 is maybe around this area, maybe around like this. Okay, and if you see, the histogram is accumulated at one area only. So you can either apply log transformation as I explained just now, or you can apply contrast stretching and make your image to cover the whole range of pixel from 0 to 255. So the idea behind the contrast stretching is to increase the dynamic range. This is what we call dynamic range. So before this, it is narrow dynamic range. So now you stretch so that it covers the dynamic range of gray level in the image being processed. So the simplest contrast stretching is using the piecewise linear function. So you can apply contrast stretching if you have the image that is poor in terms of illumination and lack of dynamic range due to the wrong setting of the lens aperture when you acquire the image. So let's say if you have the DSLR, you can adjust the aperture. But if you set the aperture wrongly, and the image you will get the image that is low contrast, where it does not cover the whole dynamic range of the sensor that available in the camera to capture the image. Okay. All right. So this is the formula for the transformation of the contrast stretching. The first step is to determine the limit over which image intensity value will be extended, which is the lower and upper limit. And then the histogram of the image is examined to determine the value limit, lower value and upper value in the unmodified picture. then you can use this formula to transform it. S again is the output. Sorry, S is the output. Okay, this is the input value. C is the original image that has the lowest intensity, lower range, minimum intensity in the original image. D is the highest intensity in the original image. B is the highest that we want. This is what we want, where you want to stretch. Okay, and A is the lowest what we want. So if let's say the original image has the minimum input minimum gray level value in the input image equivalent to the value of 40, and then the highest will be maybe around 160, so meaning that it only covers the histogram between 40 to 160, but you want to stretch it out so that the C will cover from 0, which is our A here, the output, and then the maximum will be up until 255. So you want to push it to become from 40 to 160 to become a full dynamic range from 0 to 255. So this is the formula how you can transform it. In the class later on, I will show you example if we have the image in MATLAB, the original image. Let's look at the number of pixel value, what is the intensity of that, and then we use this formula to transform it to become here. You need to know two things, one to do it in MATLAB and one to do it manually, because in your exam you will be tested on the theoretical part, on the calculation part, rather than the coding part. The coding part will be covered in the continuous assessment. So I hope you watch the video first before